Okay, so now I have this problem. Of course, I want you to use the problem from above. So up above, we saw that x minus 2 over 1 minus x. Well, we know that we can write this as x minus 2, and now we're going to have the sum k equals 0 to infinity minus 1 to the power of k plus 1 times x minus 2 to the power of k. And now I'm just going to distribute the x minus 2. And so now this is going to be the sum k equals 0 to infinity minus 1 to the power of k plus 1. Sorry, that's k plus 1, not k plus 2. Times x minus 2 to the power of k plus 1. Okay, so now where we're going to use the fact is if... So now let me write a general fact that we're going to use here. Again, this is something that needs to be burned in your mind, like I said before about 1 over 1 minus y. If f of x can be written in a Taylor series, or sorry, can be written as a power series like this, then ck is going to be equal to the kth derivative of f evaluated at a over k factorial. Okay, so now the question asks, what is the fifth derivative of f evaluated at 2? So I'm going to look at my sum, and I know that the coefficient on x minus 2 to the power of 5 is equal to the fifth derivative of the fifth derivative of f evaluated at a over 5 factorial. According to the sum, when I want to find the coefficient on x to the power of 5, that's going to be when k is equal to 4. So I'm going to have minus 1 to the power of 4 plus 1. So that's minus 1 to the power of 5. So that's going to be, minus 1 to the power of 5. This is when k is equal to 4. So the coefficient is minus 1 to the power of 4 plus 1, which is equal to minus 1 to the power of 5. And using this fact here, this is equal to the fifth derivative of f evaluated at 2 over 5 factorial. So now I just want to solve this for the derivative. So the fifth derivative of f evaluated at 2 is equal to minus 1 to the power of 5, which is just minus 1, times 5 factorial. And that's the answer.